All right, number 9 is asking if the figure has rotation symmetry. If so, what is the order and the angle of rotation that maps the figure onto itself? So rotational symmetry means if I spun this around on the center, can I make it look the same? So if I spin it, I can make it look the same because every side and every angle are the same. So in this example, yes, it has rotational symmetry, and it says is the order and angle of rotation. So it's asking us basically how many times can I rotate it. This is 8 times. And to figure out the angle, I'm going to take 360 and divide by 8. That's the rule, because a full rotation, if I turned it completely around, is 360 degrees, like a full circle. So I divide by how many times I can do that. So 45 degrees is my angle of rotation. All right, the next one is translational symmetry, why or why not. So it's important to know that the figure of a rhombus does have translation symmetry. So these are just a bunch of rhombi, the light ones and the dark ones. So this is yes, because a rhombus has translation symmetry. In these pictures, if you put the two triangles together, they make a rhombus. So this one is yes also. And translation is like another word for slide. So I could slide it over and I can get the same picture. These birds, or I think they look like birds, they do not have translation symmetry. I can't slide this bird over and get, the same exact picture because they're all facing different directions. Number 11, you fly a kite using a 20-foot long string. The angle of elevation from your hands to the kite is 67 degrees. So we're going to need a picture. Okay, let's say this is you, and the kite is up here. So the 20-foot long string is here. The angle of elevations from your hand to the kite is 67. So the 67 goes here. Your hands are 5 feet above the ground. So that would be this little space from like here to here. How far above the ground is the kite? So we would have this 5 here and here too, right? So I'm going to focus on this triangle because I can figure out this distance here. I can use trig to figure it out. In my triangle, if this is the angle I'm focusing on, this is the opposite leg, and this is the hypotenuse. When we do sine is opposite over hypotenuse. So we're going to say the sine of 67 degrees is my missing value over 20. Now to solve it, we're going to say 20 times the sine of 67 is x. So you're going to use your calculators to do this part. And it says we want to round to the nearest tenth of a foot. So when I type this in my calculator, I get 18.4 for x. Now we have to remember that we are 5 feet off the ground. So if I'm 5 feet off the ground, I have to add 5 back to this. So 18.4, and I'm adding 5 more to that, is going to give me 23.4 for my final answer. What is the exact length in meters of the side of a square with a diagonal that is 10 meters long? So here's my square. It says the diagonal is 10. What we know about a square is that we have a bunch of right angles, and we know that all the sides are the same. So I want to know how long is the side. If they're the same, I can call them both x. So I can do this a few different ways. I can use trig, or I can use my special right triangle rules. You guys have both on your reference sheet. I think trig's a little bit easier. It's totally up to you guys though. I can use either sine or cosine because these are both the same. So if I just picked sine, if I said the sine of 45 is, and I would do x over 10, and then I would say 10 times the sine of 45 is x. So when I do that, I get this number that rounds to 7.07. And one strategy I could use is I can go through my choices and see which one matches that value. So like it's not 5, I know that. And then I could go through and check my choices here. And if I did 5 times the square root of 2 and I divided by 2, that's not right. And if I did 5 times the square root of 2, I get the same number. And if I do 10 times the square root of 2, I get 14 point something. So this one gives me the same value. That's one way to do it. Another way to do it is to do Pythagorean theorem. This is like A and B. So you could say a squared plus b squared equals c squared. And you would get 2x squared equals 100. You divide both sides by 2 and take the square root of both sides. And you could see which one of these is the same as the square root of 50, and it would be C. So that's 2 ways you can do it. All right, last problem for this video. From your position, the angle of elevation to the top of the St. Augustine Lighthouse is 43 degrees. So this is 43 degrees. If the height of the lighthouse is 165 feet, how far away from the base of the lighthouse are you? Round your answer to the nearest tenth of a foot. So this is opposite. This is adjacent because it's next to the angle. Opposite and adjacent is for tangent. So we're going to say the tangent of 43 is 165 over x. Now, if I cross multiply this one, I'm going to have x times the tangent of 43 equals 165. And I'm going to have to divide. So this one was a division question. So we're going to have to do 165 divided by the tangent of 43. And we get that x is 176.9. Okay, and that's in feet. Okay, you guys have these formulas on your reference sheet. If you're not familiar with your reference sheet, please remember, you don't have to memorize these. These are down here, so you don't have to memorize them. So you have that to help you. You also have these special right triangle rules that might help you.